talked about waves because we know that some types of electromagnetic wave can penetrate inside the cell and can cause cancer. And also, we should know that some types of electromagnetic waves also can damage to the DNA, but they cannot penetrate from the space between the head of the lipid. Okay, I will tell you in more details now. Let's start with the mechanical waves. Again, similar to the situations that we had with electromagnetic waves, and we saw that in electromagnetic waves we divided it in seven category or six category. The mechanic waves also divided in three category. Okay, again, from left to the right the frequency will be increased. The first region of mechanical waves in the left is called infrasound. Infrasound, okay? And the second region of mechanical waves is called audible frequency, audible or sound, sound, which I'm talking with you. When I'm talking with you, I am using audible frequency. And finally, the last region or the third part of mechanical waves, it's called ultrasound. Ultrasound, okay? So you will see the frequency of each category. For example, infrasound, which is in the left, start from 0 hertz to 20 hertz, which we called it infrasound, and it's generally heard by animals. And then the second region, which is audible frequency, and it starts from 20 hertz up to 20,000 hertz or 20 kilohertz, which is called audible frequency, and normally it's heard by humans. Okay, and the last types or the last part is start from 20 kilohertz up to 200 megahertz or 200 million hertz, which I explained you in the first lecture that million hertz it means 200 million peaks pass through in front of your eye in second. It means that a very high frequency. So, and normally these parts of the mechanical waves cannot be detectable by human ear. Just some specific animal like bat can hear that or can detect that. So this is a first introduction slides about mechanical waves. Look at your ear. Okay, in your ear you have three different region: external, internal, external ear, middle ear, and internal ear. But in case of your ear, we should say something that we cannot hear the frequency below than 20 hertz, but this is because our external ear can filter the frequencies lower than 20 hertz. And also, we cannot detect the frequency higher than 20 kilohertz because our middle ear, and in middle ear we have a tree bone: malleus, incus, and stapes. The incus bone can filter the frequency bigger than 20 kilohertz for us, and it keeps our ear more healthy for a long time. You can use it. I mean that if your ear was be able to detect infrasound or ultrasound, probably your audible system will be damaged soon. But because of two important filter by external ear and incus incus bone in your middle ear, or ear it will be stay healthy for a long time, and we can use it for a long time. So another important point in case of your ear system is to pressure of P1 and P2. The P1, it means the pressure before before the ear membrane, and P2 is the pressure on the behind of your ear membrane, which the P2 will be, it will be justified by Eustache tube, which is go to inside the true, your true, and the P1 will be completely changed by environment pressure. So if you go inside the plane, the air pressure will be decreased, so P1 will be decreased, and your air membrane, which will like a bump and inflamed, and so you will feel some things like I don't know, a specific sound in your ear, which sometimes it's like harmful for you. But in any case, in our ear, this two pressure, it's like more effective on the in I mean that on the output of your hearing system. I means that in the best situation, if you have a P1 equal to P2, your ear is it's in the maximum sensitivity, maximum accuracy, and maximum efficiency. Okay, so this is it was for a human ear, and also again the last things which I want to talk with that for the moment is your external ear compared to the external ear of elephant is very small. I means that the area of external ear of elephant it's about magnitude of 10 times bigger than the external area of your external ear. But your small external ear can detect many frequencies between 20 hertz up to 20,000 hertz. But this big external ear in elephant just be able to detect the frequency of between 1 hertz to 20 hertz. This is because in our physiologic system is more modern than elephant. For this reason, the elephant external ear is applied for cooling the blood temperature of elephant. Okay, but in the human, we don't need this for cooling the blood temperature because we have a modern mechanism for control the blood temperature in human. Okay, for the moment it's enough. You can have a short break. I will return back at 10:20. Is that okay? So I don't stop. I don't stop anything. Just I will close my microphone and I will return back at 10:20.